Hello my friends, welcome to this fairmaths channel. Today we are going to talk about a new topic that is nothing but the theory of equation. In this chapter we are going to learn about the equations, not all equations, but we are particularly giving our focus on polynomial equation and how to solve their solutions. Okay, now let's introduce this topic by see this problem. Okay, we know a circle and a line never intersects more than 2 points. So here we have 2 points, and over here one and over here another one. But is it possible to intersect more than 3 points? That is, the line has 3 intersections. It is not possible in a circle. But how can we prove this statement? But okay, we know this, but we can't prove this. But there is a way to prove this. Okay, let's see how to prove this thing. Okay, we know let's consider the circle, the center at the origin, and r is the radius represented the circle, and the circle in the xy plane is represented by this equation x square plus y square equal to r square. We all know this thing. This equation is in our 11th standard too. And also we know that in same xy plane the equation of a straight line is given by ax plus by plus c equals 0. We already know this thing in our 10th standard. Okay, if we solve these two equations simultaneously, we get the points of intersection, but this equation cannot contains more than 2 solutions, so we have only 2 intersection points. It is possible to have one intersections, that is nothing but we have, if the line is passing in this direction, then it intersects at one point, but it is not happens if we use this equation to say. But it is possible if the both values are same, that is x equal to y, then it intersects at a single point, that is the same point. Okay, now let's introduce the polynomial equation. The polynomial equation is nothing but, it is, first of all, moving on to polynomial equation, we have to know what is degree of polynomial and what is a polynomial function. Okay, first of all, I will explain you what is the degree of an equation. A degree is nothing but the highest power in the overall equation. Over here we have an equation. It may be infinity, but the highest power over here is nothing but this is the highest power, because here n minus 1, and over apart from that we have n minus 2, n minus 3, n minus 4, and etc up to n minus n minus, okay, etc like that. But this is the highest power, so that the degree of this equation is n. Okay, and we have to define this. This is a general function, but the polynomial function is defined as nothing but p of x equal to a n x power n plus a n minus 1 x power n minus 1 plus etc plus a 1 x plus a naught. Okay, over here we have to notice that this has a power of 1 and this has x power 0. We know that anything power 0 is 1, so we have neglected the things. Okay, we have like this, p of x is equal to ax n plus a n minus 1 x power n minus 1 plus etc plus a1 x power 1 plus a naught x power 0. This is a polynomial function. But what is the polynomial equation? Polynomial equation is nothing but polynomial equation if we have this equation equals to 0, or if this equation is equal to 0, then the equation is said to be a polynomial equation. And this is possible if and only if we are just simply representing this x as c over this equation. So this equation is always a constant, then the c is said to be the root or solution of the polynomial equation. Most of us confuse both the roots and solutions of an equation, but both of them are same. That are nothing but the variable in this equation have some constant values to get equals to some particular value, over here 0. So those values are said to be the roots of that equation or solutions of that equations. Okay, let's see. Okay, we know that this is the polynomial equation. Just remarks, what we are getting from this equation is nothing but, just see one by one. The polynomial functions are defined for all values of x. For example, if we have two values for x, then each value will be separately equates this equation or follows this equation. So we have like that. Okay, and then every non-zero constant is a polynomial of degree 0. I already mentioned that. Over here we have a non-zero constant. This is a polynomial of degree 0, because I already mentioned anything over 0 is 1. So we are neglecting that x power 0, so we get a constant. So we can generally say every non-zero constant is a polynomial of degree 0. Okay, the constant 0 is also a polynomial called zero polynomial. We have to notice that every zero is a polynomial called a zero polynomial, and the degree is not defined because there is no power for it. We can say any power for 0 because it remains same for anything. But over here we are doesn't mention that because it doesn't change the mere equation, so that we doesn't mention, but we have to remember that the 0 is also a polynomial and it is said to be a zero polynomial, and the degree of polynomial is a non-negative integer because, okay, over here the greatest number must be a positive integer, because for example one can say if we can have a negative integer, for example ax power minus 1, but it is value we have a value of x power 0, so that we can't say the degree of the polynomial is 0, sorry, negative, so that the degree of a polynomial is always a non-negative integer. The next one is the zero polynomial. We already mentioned that the zero polynomial is nothing but the 0 in the equation is nothing but it's the only polynomial which has a coefficient of 0. The coefficients are nothing but we have mentioned over this equation a power n, sorry, an minus 1, a1, a0. These all are the coefficient. The zero polynomial is the only polynomial has a coefficient of 0 because other have some other constant values. Okay, next one is the polynomials of degree 2 are called quadratic polynomials. Okay, for example, if we substitute n is equal to 2, then we get a simple equation which has a degree of 2, then that equation is said to be a quadratic polynomial. Then the polynomials having degree 3, then it is called as cubic polynomial, and the quadratic equations, or sorry, the polynomial equation having degree 4 are said to be the quadratic. Over here we have quadratic, but over here we have quadratic, but over here we have quadric. We have to differentiate between them because we will confuse both of them. So we have to differentiate quadratic and quadric polynomials. So we are already familiar with the quadratic polynomials. Okay, but once again we have to revise them. Okay, now what is quadratic equation? Quadratic equation is nothing but it is in the form of ax power 2 plus bx plus c equal to 0, because we already saw that the quadratic equation is in the form of the above said value over here. But if we substitute 2 over here, then we get a quadratic polynomial equation. So we have quadratic polynomial equation which is in the form of ax square plus bx plus c equal to 0. Then if we have a polynomial equation which is equal to ax square plus bx plus c equal to 0, then the b square minus 4ac is called the discriminant, and it is denoted with the symbol del or delta. It is a Greek alphabet. Okay, you already familiar with this term in your 10th standard, 11th standard, and in your physics books. Okay, what is the purpose of this b square minus 4ac discriminant? It is nothing but, let's see in the furthermore topics. Okay, now let's see. We already know that the two roots of the equation of the given by, because we already know this formula in our 10th standard. There is nothing but x is equal to minus b plus or minus root of b square minus 4ac upon 2a. We can split this equation into minus b plus root of b square minus 4ac upon 2a and minus b minus root of b square minus 4ac upon 2a. These are the solutions for a quadratic equation, because a quadratic equation has a maximum of only 2 solutions. Okay, from this we can say a must not be equal to 0, because if a is equal to 0, then we have infinity. Okay, now let's say, okay, now we have the uses of this discriminant. Okay, let's say let's remember this thing, the discriminant delta, which is always equal to b square minus 4ac. By knowing the value of discriminant, we can say delta, if delta is equal to 0, then the roots are equal, that is nothing but x equal to y. If delta is greater than 0, that is nothing but it's positive, then the roots are real and distinct, that is nothing but we have distinct separate roots, both of them are distinct, not equals. And if we have delta is less than 0, that is nothing but the delta is negative, that's the discriminant is negative, then the equation has no real roots, it has imaginary roots. Okay, now this is the end of the session. If you like this session, please like this video and share and subscribe to this channel. Okay,